Hi, I'm Christian Hergert. I'm a longtime free software contributor. It's my second time speaking at Scale, but when I used to live in LA, it's like my favorite conference around to come to. So super excited to see that we have a room full of people here that are interested in hearing about what we're doing in GNOME. So I guess we'll just get started as people funnel in. I assume that most of you know what GNOME is. GNOME's a free software desktop. And we've been around for about 15, 16, 17 years. And one thing that's really permeated through GNOME through its entire history is a care about user experience. You know, we had a little bit of a hard time getting started in the first, if you ever use GNOME 1.4 on Red Hat 7, we were all, I can't remember the term that Jamie Zawinski used on us, but we're attention deficit children. And yeah, we had lots of really big buttons and menus and stuff. But by the time 2.0 came out, we focused really on user interaction and user design before that was really ever a thing. This is really common in GNOME that we come up with a lot of these, what ends up becoming the standard way we do things. The project has come up with a lot of those, like the 6-month release cycle that, the cadence, as Ubuntu would call it. That came out of GNOME in the early 2000s. We also tend to expose bugs in the stack because we're really trying to push forward the desktop. GNOME 3, I'm sure many of you had problems with your graphics drivers early on. It's because we didn't really have particularly great 3D graphics drivers at the time. And we really lucked out that at the same time that GNOME 3 was pushing this forward, VMware bought this company called Tungsten Graphics. And they bought Tungsten Graphics to do scientific computing on virtual machines, and so they built this thing called Gallium 3D and this entire great 3D driver stack, and it also happened to fix a lot of our problems that we had on desktop Linux because they had to implement OpenGL correctly and deal with all of the shader compilers, all this wizardry stuff. Also the same thing for audios. I'm sure everybody's dealt with the pain of pulse audio or whatever at some point in time, but these are hard problems that had to be solved, and for better or worse, they have some pain associated with them. But the main thing, this ethos in GNOME, is that we go fix the problems in the stack wherever they exist. So you'll see a lot of what's on a modern Linux, like a modern Linux desktop and a server, has, some people might say tentacles, but other people might, loving care of hands of people from GNOME that have tried to go down and fix the problem that were causing us pain. We generally don't just work around bugs, we try to go fix them at the source. So a couple examples of this now. Graphics drivers and display servers like Wayland. Christian Hergert is a longtime contributor to the GNOME ecosystem. Network configuration like Network Manager, audio subsystems, pulse audio, message passings like dbus, G settings. Actually starting an application race-free is a non-trivial thing on Unix, so that was something we had to solve as well for applications that we have a single instance of. Like if you start 2 programs at the same time, they might both try to access, Firefox might try to access its profiles directory in .mozilla. This is why you can't actually have 2 users and 2 graphical sessions logged into the same computer today. We talk about we have a multi-user system on Linux, but the reality is we have a multi-user system as long as you're different users. If you have the same user trying to log in twice to the same system, both with a graphical session, you're probably not going to work because everything's going to try to collide with each other. The current things going on right now, of course, if you saw any of the earlier talks today, like systemd, Leonard Pottering is a longtime GNOME contributor as well, and application sandboxing. This is the new thing we're doing right now. This is, if you're interested in sandboxing and really bringing down, tightening the security on the applications that run on your platform, this is a really good time to get involved because it's very early. We just started on it in the last few months. Alexander Larson is really running that forward, and fantastic engineer, and is definitely looking for input from people on the outside of things they want, and if you have an idea of how something should be implemented, it's a really good time to speak up. So just a little bit of background about me. I've been working on glib, G-Object, GTK for a long time, a good 15 years. I worked on MongoDB at a previous job, on the database implementation. I worked on virtual machines at VMware. And before that, I was a longtime contributor to Mono. So that's a JITted, garbage collected, runtime language, and just general language geek. But this summer, I had to make a really important move in my life for me to be happy and fulfilled, and I quit my job at Mongo because free software to me is like the most important thing that's been in my life through the entire time. It's what I learned, it's how I got my career, and it's how I've sustained my career thus far. And if you are familiar with Andy Hertzfeld, he was like the first Macintosh programmer. He had this quote years ago that when he started this company called Easel, they built Nautilus, the file manager. It was a commercial company that set off to do this. He said the reason he had to do it is because he was bitten by the free software bug. And for me, that explains everything. That's really what brought me into this community. So I quit my job to do free software, but in particular, I quit my job to work on GNOME, and even more specifically on Builder. Having been in the free software community for this long, there has been one piece that has permeated through the entire time, and that is that our tools have always been good enough to get by. Never have they been just absolutely amazing, fantastic. Like, we've built great things, but the process for us to go build those things has largely been a huge pain. GCC is fantastic. That's a great thing that was built. But when we're building our projects and tracking down portability issues and all these other things, it's largely a huge pain. So let's jump for a minute. What is like GNOME as a larger ecosystem? We have a lot that goes into a modern system. If you think about like KDE or GNOME or Unity or any of these full-featured desktops, it's not just a window manager like it was 20 years ago. It's an entire ecosystem of things that have to go together. We have to build APIs for people to build applications. We have to build graphics toolkits like GTK or Qt. Build tools like Automake, AutoComp. Some people use CMake. Some people use QMake or whatever the mock it is on Qt. You know, we need media pipelines like GStreamer. If you want to be able to play audio and video, which presumably everybody does at some point in time in the day, you need an entire pipeline for codecs and all that type of stuff. We need file system abstractions. We need email notification layers, location data, input methods, because not everybody speaks American English. Which is, I don't know if you've booted your Linux system and actually looked at the terminal output from the kernel on boot up. You notice how everything's in ASCII? That's not because everybody speaks ASCII. That's because it's incapable of rendering UTF-8 data. So yeah, and also I think that brings up a tangential point later that like the Linux kernel community wants to get rid of the font rendering in the kernel. So that's probably going to be another thing people are going to clamor about. So yes, a lot involved in making a usable desktop. And for better or worse, it gets bigger every year. Everybody wants new features. Everybody likes this new app, this new thing that they can do with their computer or their phone or their tablet. So every year we have to continue to maintain more and more infrastructure. And our community is not exactly growing in terms of the number of people. Like, we get new blood in, some old blood leaves, goes to a different thing, goes to OS X, does whatever. We're pretty constant with the number of contributors you have. So because of this, in 2012, I tried to make a really bold statement. And I said, email me and I'll teach you C. I had the intention of only teaching like 1 or 2 people. And it was mainly because I wanted to see if we could come up with some materials. But my inbox is still full. I had thousands of people email me to the point where I could not keep up on my email. That's thousands of people that cannot contribute to free software today that want to be contributing. That's huge. We have thousands of people that could be in this room right now contributing to free software, and they don't know how. Or they don't have the skills that they think that they need to be able to contribute to free software. And this is for C. Like, I get it. I'm a dinosaur. I like to write C. Not everybody wants to write C. Like, imagine if it was Python or JavaScript or any of these other languages that people are actually interested in today or are getting started in, HTML, CSS, JavaScript. So do keep in mind, I don't think you should learn C, despite the fact that I'm writing an IDE in C. We have a lot of infrastructure on Linux that is written in C. That's probably not going to change, because for us to change to a language other than C would mean we have to pick a favorite, and it's just not going to happen. C is that common denominator that all languages can talk to pretty much. So for better or worse, we have a lot of infrastructure in C, and if we can have more eyes looking at that code, we have more warm bodies dealing with the bugs, we're all going to be better off. But the important thing from this was that I failed miserably at teaching very many people C. And I really had to think about why that was, and it was, of course, you know, like I start with it's my own personal failures, I should have done better, I should have done something different. And then I had to sit back and actually like analyze what the people were asking me for, why they couldn't understand the topics or the technology. So this right here is really important. Learning how to get started is the most important part and the most difficult part of contributing to free software. How many of you have sat on IRC asking questions and not gotten a response? Yeah. This is why outreach is so important. And this is why I'm building Builder. Because we need something that helps people get started from ground zero, from not knowing anything other than I'm using a computer, I'm using Linux because it looked really cool, my friend had it, and I want to use it myself. We need something that is so simple that it is just enabling a developer mode switch. This is really common on the Android phones, right? You go into the settings, you find the little magic thing, you tap the button a couple times, and then like the developer mode turns on. I don't think we need to be all clever with the taps or whatever, but like we need something that is just you turn on developer mode and you now have something that can guide you through the process of creating software from ground zero. So then you might ask, you know, why don't you just use one of these other IDEs? There's other IDEs out there. Some of them actually work. But none of them are focused on our community and our platform. They all try to be everything to everybody, and in doing so, they help very few people do much. This is another really important part. With the work that I've done on trying to help people get started with free software, we know that it's really tough to get started. We also know that there's not enough of us to see and work with everybody individually. There needs to be something that will help people get started and guide them through that. So with Builder, once we actually get the IDE in place, one of the important steps we want to do is build tutorials into the IDE. So when you get started, you can basically say, I've never written a program before. We have a really interesting piece that we can help you with by being an IDE. We can look at the code you're writing in the editor. We can analyze it. We can tell you whether or not you've done something correctly. I hate to use the word gamification, but like we can actually tell you when you've completed an exercise correctly because we can see the code, we can analyze it. And I also think this would be really neat if anybody's working in schools or with professors or whatever that want to put their course materials together. I think it would be really interesting to be able to have a set of course materials that is completely built in the IDE, and you get to work yourself through that process on your own time. Also, if you have to learn auto tools, like we're in really, really bad shape. And that's coming from someone that uses a lot of auto tools, and I like it, and I generally, that's the first thing I do is I set up a new auto tools build system, and then I start writing code. But if you have to learn 35 years of neckbeard to be able to write a simple desktop program that like is a Twitter client or something, then not only do you have to learn the language and the APIs, you have to learn this arcane build system that's the way it is because at one point in time we had 30 different Unixes to deal with. So I guess, where are we going? What's the plan? Right now we are very, very early on. So this is not a full-featured IDE. This is not a replacement for Visual Studio or Qt Creator or Eclipse or NJuda. We're very, very early, but there's a lot of people that feel very similarly to me, and so we already have like a very large number of people that have contributed. And now I'm full-time working on this. As I said, I quit my job last summer in September, and I paid for the first 4 months myself. And that was so that I could build enough to give people an idea of what I'm building so that you could contribute to help me build it for you. So I then did a crowdfunding in January, and we were able to raise up enough money so that I can work presumably the next half year, possibly more, depending on like what the IRS says. But together, we're building a new, fully functional IDE for GNOME. All the modern features you're used to from everything else, like auto-completion, auto-indenters, build system abstractions, version control, documentation built in. As you can see, there's a lot to do. Code search, I think, is actually going to be really neat since Google dropped Google Code Search. So when we get to the point where you actually get back into databases and get to write some really cool code search things. Like if you're familiar with writing databases, there's a concept of bigrams and trigrams, and it's how you like take apart all of these individual pieces of words and put them together into an index for you to search for things. So you could say like, show me everything that is if followed by no curly brace before a semicolon, and like warn on that because you're not following some coding guidelines. One of the interesting things in here is the external hardware devices. We did reach far enough in the fundraiser. So you're going to be able to plug in like a tablet or an ARM device or Raspberry Pi, and you'll be able to discover that device. It'll come up. We'll look at, discover what it is, and be able to cross-compile for it, assuming that you have an appropriate cross-compilation toolchain available on your system. So this will be really neat if you get a Raspberry Pi and you want to write some little C program or whatever language they're using on there, run it. You just basically build, it'll deploy it to the device, it'll set up a debugger for you, and you can debug locally on your machine without having to go to the Raspberry Pi, copy your source files over, build on there in a really, really slow GCC, and then run it. And that dev cycle that takes you minutes and minutes, you can get down to a couple seconds. And also, as an aside on that, I met with the Raspberry Pi people in Cambridge, and it sounds like there might be some interest in doing a follow-up fundraiser that is a matching grant type situation. So we may have a follow-up fundraiser, depending on how far we get in timing and everything, that we'll be able to really expand into the Raspberry Pi ecosystem. But the most important thing for me is that all of this is being done with the same attention to detail that we put into GNOME. GNOME is known for detail and for reducing complexity. And I think that goes into developer experience as well. Just because we're developers and we're engineers does not mean that we want to see 10,000 toolbar buttons across the top of the window. I mean, have you ever used the copy and paste toolbar button? Ever? I haven't. And for short, we're calling this developer experience. So because we're on this 6-month release cycle, this cadence that we haven't missed, I don't think, ever, we're shipping GNOME 3.16 in 5 weeks. I doubt that we're going to have a really compelling builder for people to be able to use every day at that point, but we are going to have a pretty cool pre-alpha that'll be out by then, but it won't be able to do a bunch of these features like external hardware and debuggers and stuff. So that's more of like a 3.18 goal. My hope is to have demos for people to use by GWADEC, which is our big European free software GNOME conference. So the real question is, what do we have today? Right now, Builders is being developed in 2 pieces. We have the UI, which is like the editor and all the different component features you have. And then we have libIDE, which is it's an IDE as a library. And so that's kind of neat because it's a shared library. You can write your own tools around it and stuff. And the UI Chrome is minimalism, like everything else in GNOME. I'm not going to say it so far as like Zen minimalism, but we definitely care about not putting things in front of your face, because we want you to be able to look at code, because that's why you're in an editor, right? You're there to write software. It's one of the really compelling reasons about using Vim or Emacs in a terminal is that your entire screen is code, not all of this other junk going on. Here's an example of what it looks like today. I can just point out a few things. It's kind of like you'd never use it quite like this, but, and this is a little bit early on. Some of the stuff is moved around. Like the top, we have this thing, is code navigation. If you've used Vim, there's a command sequence called Control-O and Control-I, and it lets you jump back to your previous edit positions, even if they're between files. So we're building this really robust code navigation that allow you to like jump context without having to keep tabs open for everything. Because you've seen Firefox, like jumping tabs in Firefox is a nightmare. Everything's really based around search. So there's a really prominent search bar at the center on the top. That means like get search, like opening files, jumping to symbols, finding documentation, searching Bugzilla, all of that type of stuff. Or even running commands, like if you want to submit a build command and you think you're faster doing like :build than you are pressing a keyboard shortcut. I know I do that a lot. I do like :make in Vim more than going to another tab. Search, we do have a not complete Vim implementation, but a really robust Vim implementation. Because for me to get out of Vim, I had to have modal key bindings and all of that. So if you're familiar with Vim, I would say it covers about 90% of the daily stuff. I didn't implement registers, and I didn't implement file marks. If you use either of those two things, I suggest you submit a patch. Search, I don't know, it's kind of like bubble search type results like in Safari if you ever use that on Mac. Some things we share with gedit because we're really good about sharing code upstream. Some of this top bar here is going to change, but we can do vertical splits, horizontal splits, as many horizontal splits as you want. And yeah, the buttons in the top are unsensitive right now, but yeah, we'll have a bunch of stuff for like adding G-objects and adding widgets and adding dbus services. So it'll be really easy. If you want to like consume a dbus service, you'll just be able to browse to the dbus service running on your system and basically say implement. So now if you want to talk to systemd, it's like, it'll be like a couple minutes and you can have something up and running. This, of course, was just the editor component. We're going to have, it's going to be built into workspaces rather than having panels that are floating everywhere. Used on Visual Studio, right, where the amount of window you have to write code is like 10% of your screen real estate. We're treating things a little bit different in terms of workspaces, so the whole different workspace will slide in. And Nemover is our graphical debugger in GNOME. It's written by someone that spent a lot of time working on GDB. It's incredibly robust. It's very well implemented. It happens to be in C++. It's another reason why we're doing this in C, is because we need to include code that's been written in Vala, code that's been written in Python, code that's been written in C++. We need to be able to like bring all of that together. GitG is a Git GUI front end, really well written in GTK. It uses WebKit as well. DevHelp is our main documentation engine, and Glade has been around forever. So I'm sure people are familiar with Glade and probably don't like it, is my assumption. We have a lot to do. We have a lot to fix in Glade. It's a project that's been around forever, and it's a really difficult problem historically because of the implementation of GTK. But we've basically ripped up all of GTK over the last 2 years and rebuilt all of the infrastructure, so a lot of things have gotten really easy. So if you want to make an application that has some crazy theming, you can theme GTK now in CSS. We have like an entire box model from like a web browser that we built into it. It can do animations. Like you can do animations in GTK with CSS. We're going a little bit overboard with it recently, but it's really cool and you can do it. And we need to build a project management system that manages your automake stuff. Some of the stuff's in there now, but as always, there's a ton to do. So libIDE is under heavy development now. It's basically what I've been working on since FOSDEM full time. So what does it do for us now? Not all of this is fully implemented, but the scaffolding for everything is there. So as you can see, I've been really busy in the last few weeks. Of this stuff, I'll just let you soak it in for a minute. And I hope you like my D&D reference. One of the nice features we have with the live diagnostics, so this is like as you type, we're using Clang in the background to tell you like whether or not this is going to compile. So you see like the whole squiggle underlines like you would in spell check or something, right? Like as you type. And yes, we are using Clang. I'm a GCC person, preferably. I much prefer the free software license of GCC. But until GCC is usable as a library, we're going to continue using Clang. Because there's some things, like we have this choice of like, do we want to stick to free software ideals and wait for whoever in the GCC camp is preventing some of the stuff being implemented because of exporting AST backends or whatever they're worried about. Commercial companies being able to use GCC to make proprietary compilers. So until they figure out what that ecosystem is going to be and allow us to use GCC externally for these features, we're going to have to take the compiler that allows us to do this, because we're not going to like hold back our development platform while we wait for them to figure out what the free software ethics are. We're going to use a free software compiler. It just happens to be Clang and BSD licensed, which is not my preference, but we need to move forward and we need to make progress, because otherwise we just hold back the entire community. Build systems wise, we're supporting AutoMake and AutoComp first. Someone came up to me at FOSDEM and wants to implement support for Meson. It's like a new build system that compiles to Ninja, some Chromium stuff, whatever. It's super fast. So we'll probably end up supporting that. I've heard people want CMake. Depending on how much people want that, we'll end up implementing it. We're focusing on Git. Is anyone here using something other than Git? Bazaar. Okay. So that's, yeah. We might support Bazaar if someone can write that code. Yeah, I mean, otherwise I would just say, like, someone should write a Bazaar to Git bridge. Yeah. Editor settings. I just found out about this other one called editor config. It's kind of neat. People seem to be using it. So I implemented support for that the other day. We have that. Mode lines, like, you know, normal Vim, Emacs mode lines, all that type of stuff. Everything's in there. Almost everything in here is asynchronous, so we don't ever block the UI thread, because who wants their system to block? But the main thing is all of this is written in C, but we also did it in such a way that we interact with Object Introspection. Are people here familiar with Object Introspection at all? It's just a really neat feature. So we basically have a second compiler run when you build a library with Object, and what we do is we extract from your headers the information about your C library, and then we make a really small program that links against it and calls into the Object type system to extract the data at runtime. So between those two things, we can pull out everything we need to know about your library, and we compile that into an XML file that's like a description of your library. We then make a binary M-mappable version of that that's really efficient data structures that we can just load into memory at runtime. And it allows us to build language bindings for a particular language at runtime. So if you do, in this case, if you were to import in Python, I think it's like from gi.repository import IDE, it would bring in libIDE. You'd have classes in Python. It would feel Pythonic, as if I wrote the entire thing in Python, but it's all written in C. And all the reference counting works between the languages. You can do this in Python. You can do it in JavaScript. You can compile ones for C++ and C#. It gives us like access to this huge variety of languages, even though we wrote everything in C. So for an example here, let's take a look at like what it would take to hook into every time you save a buffer using libIDE, you want to translate something. And this example is in JavaScript. You could also do it in Python, and it would look like almost exactly the same, except for instead of function, you'd probably use lambda, and you wouldn't have let. So you get access to the buffer manager. Everything lives in context. So like when we set up the JavaScript context for your scripting environment, we load in this special variable called context. That's your IDE context. And if you technically had two projects open with libIDE, they would each have their own context, so your scripts wouldn't like clash with what they're doing. So we just connect to the event that is the save buffer event, and this will all be documented really well with the library. And then you get a callback, and you get the buffer in the callback, and you can just get the text from the callback, replace, you know, carriage return, new line with a new line, and then set the text. And now when the next layer goes to actually save the file, it gets the buffer with the translated contents, shoves that out to the external system. So the same thing here. Maybe you want to automatically build for a device every time you plug it in. Like maybe you have a couple, 2 or 3 phones, and it's really annoying. You have to like plug in the phone, then you have to build for the phone, and then you have to run it. Maybe you just want to automatically connect to the device added signal and start cross-compiling for that target. So in this case, we can connect to the device manager. We get notified that a new device has been added, say like an Android device or some Ubuntu phone or something. And then we just check that it's not the local device. You could do something special there if you want. And then just get a builder for it and then call the build and let it build asynchronously. If you care about when the build is finished, maybe you want to deploy it to the device and then run it, you could pass in another function and be like, I guess it would be like Node.js where you're just like nesting function asynchronously like over and over and over again. But essentially that's how it would work. So those aren't the only things you can do. Basically, anything in libIDE is extensible through this. So you could build your own search provider if you're using like Bugzilla, or if you're at Canonical and you want to search Launchpad. Whatever your bug system is you're using could be implemented through basically just JavaScript file that you drop in your home directory, in a special directory. And the idea there is that we can share some of these scripts. So if I write one that's doing Bugzilla or something that you could just, it's not quite ready to go in the upstream version of Builder, but it's usable for other people in the meantime. You can just kind of like share these scripts around in true open source fashion. You can implement build extensions, or maybe you have a new device that you're working on at a company and you want to make sure that it works like with this, so you can just quickly build and deploy things. You could implement the device lookup. So maybe you get a UDEV event for when your device got plugged in with a particular USB ID or PCI ID, and then you could add that device to the device list so that it will show up in the UI, and the UI would allow someone to select that as the target device and then hit run or build or debug. Also, another one might be interesting is the refactory tools, because you'll get access to Clang and everything in there as well. So you could technically write Clang, not necessarily Clang plugins, but you could write Clang scripts that would go through your source repository and manipulate whatever, all from JavaScript. So this is all the different things that go into an IDE. You notice there was something to do with UI there, but everything that goes into this process and building it and how these little things interact. If I do my job right, you won't really notice that they're there. You'll just care about the UI. So that's most of what I have. I can go into demo stuff if people really want to see things. It is early, but I'm willing to do that. If you have questions or things you want implemented. So it's kind of like a two-step process. The first process, oh, sorry, is the question was, is Builder being targeted at new developers or existing developers? And the first step that I think is important for any developer is to be running their own software every day. So the very first step was bootstrap. Let's be able to build Builder in Builder. So that means we need to focus on being able to have some pretty decent C tools. And since GNOME, for better or worse, is like 90, 95% C, it's important for our existing community to be able to use this so that they can contribute things to it. So that C has definitely been a focus. But that said, there's a lot of people that don't want to be writing C. So, you know, immediately after bootstrapping, it's like, can we support JavaScript? Can we support Python? Can we build tutorials into the IDE? And I'm going to need help for that, because writing takes a special type of mindset that I'm not going to be able to do well myself. So I'm definitely looking for people that are interested in writing tutorials or platforms, like anything they can do, especially if you really want to experiment with the joining of the area where you write code with how you teach people software. I think we have a huge possibility there. I don't know that we have any source up there. So like if you mean integration in terms, that's definitely a different level of like going from absolute zero knowledge, and something that's like, I'm sure we would like to do, but it's hard when it's not in the context of like Linux or desktop Linux or GNOME to start with teaching someone out of that context, right? So I do think that we probably want to be somewhat focused on like, this is our ecosystem and like, this is how you build for our ecosystem. But yeah, I mean, maybe we can get some content externally for that. I mean, I'm sure there's copyright issues and things we'll have to deal with as well. So, yeah. So the question was, what's the demographic of our user base? And you know, the demographic of the user base that we have today is very different than what I anticipate the demographic of our user base in a year or 2 years, right? If we do this well, you know, the number of people we have contributing today will be dwarfed by the number of people contributing tomorrow. It's that hockey stick, right? If we do this well, that we can really bring in a lot of people. And the people that are contributing today are largely uh, you know, the full-time people that are doing a very large amount of code are obviously employed at someone like Red Hat or SUSE or something to that nature, Igalia, Collabora, CodeSync. But we do, in terms of lines of code, have a very significant number of lines of code contributed by people that are not affiliated. They're either in school, they're currently in between jobs, or you know, high school. We have a lot of people that are contributing, you know, in their teenage years as well to the project. So the people that I've been getting emails from that want to join our community is a huge range. I've got people that are like 65 that are like, I want to learn how to program C because I never learned. I was in IT. I lived through like the IBM era and then the Microsoft era and all this stuff, and now I just have free time and I'm retired. And that's really cool to see. And then we have other people that are like, I'm 12 years old, I'm going into high school, and I want to learn how to program. And then everything in between. So I didn't do statistics on the people that have emailed me. I tried not to like ask people personal information like that, just out of like respect to them. But you can get some of it out of it because they just tell you, like, this is my story. Will you please like consider me? So yeah, we have an entire, you know, gamut of people that want to contribute. Demos? I can show you Vim mode. I like Vim mode. I also haven't tried this at 1024. Let's see here. Oops, sorry. And get a test project set up. Cool. Yeah, so I actually don't have it installed in my normal user. I just use it in JH build. So this is an example of the basic search today, and it just pulls things out of the Git index. I don't have it doing like the Git grep, all that type of stuff yet. That's coming hopefully in the next couple weeks. So if I just want to switch to a particular implementation here, you can see this is like the live editing. I don't have UI connected to it yet, but it would be pretty easy. We can run build here. And in the background, I'm sure if we watch it with htop, I don't have it proxying data and stuff across yet either. So actually, let's see here what's going on. Perl's running. Sounds like automake. Okay, cool. There's the build. So I am missing a package because I just set up my machine. And I am missing the data. Okay, so the important thing here is that we have, to test the libIDE, we can do the normal thing, right? Like whenever we're building and doing our normal development work, we're running make check to make sure that all our unit tests pass and all that type of stuff. But you'll see here is in the linker, what it's generating are a bunch of test programs. And test fail, yay. And so these different programs we can use to test particular parts of the IDE, but they're also going to be really generally useful for you developing things if you don't want to use the full UI. So like IDE list files helps me like test to make sure that the project loader system extracted all the files from a particular test project that I have. List diagnostics is like a Clang style output. It's like you ran the program at Clang and it gives you warnings. Except for because we have a language abstraction in Builder, it works for anything. So whether or not it's a Python file, we should be able to do list, IDE, list, diagnostics. We need to pass it the project file at the moment. I'll probably change that soon. And then we'll just choose IDE buffer.c. JH build run. So this is really familiar, right? Like Clang style output, you saw GCC compile error. You get like the position where actually the error started, which is very similar to the error underline you saw in the UI. And, shouldn't really look that new to you, but it's not actually Clang. So we're like pretending to be Clang. So if we just do like test.py here quick, we'll just like, do a shebang and make like an invalid Python file, right? Hopefully I have everything set up correctly for this demo. Yes. So this looks an awful lot like Clang as well, except for we're actually like using Python. So like very familiar, convenient error warnings or whatever. And I think we can even do it for JSON. We'll like do an invalid JSON file. Same sort of deal. So having all these like nice predictable tools, whether or not you're inside an IDE, now this could actually be used by Vim if you set the error mode for Vim. So like all of a sudden you can have error warnings in Vim as well, using the things we're making for Builder, even though you don't care to use the Builder IDE. So we're trying to build things in a way that like we're going to provide you an IDE that has everything built in, but if you don't want to use it, you're not necessarily going to be hampered. We're still going to build you the tools. Another thing here that's useful as well, we integrate with Git, so we know where all your changes are live as you type. Let me see if I can do another quick demo. Oops. So if you're really familiar with doing G-Object, there's a ton of boilerplate in doing G-Object-C, or well, there used to be. We have a snippet system here you can go through. If I want a new G-Object, there we go. It's a test object, it inherits from G-Object, and there's actually not very much boilerplate. If we want to do a final class instead of a derivable type, it gets even better. We can go there, we can delete this. So now that's a pretty competitive to build a class in C comparative to, say, a C++ class. So it's like way nicer than what we've had in the past. And do the same for the C file, say LGPL header, and maybe want a G-Object class. We can work our way through the snippet system. So we have a bunch of these snippets. They work for a ton of different languages. If you want to add some, let me know. We'll go in and get them in there. So yeah, that's what it's like writing G-Object-C. You can see there's a lot of boilerplate, but for the most part, it's not too bad anymore. Yes. So all these snippets are on this slide? So you are using some kind of template? Yes. Yes. Can you show what template? I can. Let me bring this up. Let's take a look at, so you have snippets for a few different languages here. Take a look at the G-Object ones. JH build run. So it was loosely based off of SnipMate, which was loosely based off of TextMate, except for there was other things we wanted to add. So we wanted to be able to define a scope so we wouldn't have to have the same snippet for multiple languages, just duplicated all the time. So just to kind of like DRY ourselves. We added a scope extension. Then we added an extension for describing the snippet, so we could show that in the IDE when you like autocomplete. But the main thing is a tab stop within them is defined by like $, open curly brace, and then the number for the tab stop, and then colon to say you want to define what the default value is. And then there's a couple of these things built in, like $file name is obviously the current file name. And then you can pipe them to some filter functions. We have some built-in ones like stripping suffixes or converting to camel case or function underscore function names, or like grab what the namespace would be for a name versus the object name if you follow pretty normal G-object conventions. And then you can work your way through them. But as you update any of them, all of the others update. So like you get, as you type, all like the newest version of the file. It's really convenient because some of the other snippet systems you have to update, and then you like tab to the next tab stop, and then all of the rest of the items will update only at that point. We keep track of everything as we go, and it feels really nice when you're using it. Anything else in here that's somewhat interesting? Some hacks here, because I always hate when I use snippets and like stuff doesn't align. So like we have some different things in there you can use to like convert what the input was to like spaces, and then everything else just looks good afterwards. Let's see here. What do we have in Python? There's, some simple normal ones in Python. If someone wants to come in here and that does a lot of Python, let's see here. In fact, this looks broke to me. Someone didn't use tabs correctly. License ones. These are a good example of the scope, right? Like having to do an LGPL header for every different language is pretty annoying. Preferences wise, you know, if you want to find preferences quick, we have live search through those. We do have the Vim mode. We have Emacs mode that landed this week. Some basic Git stuff. Auto indenters, matching brackets, overwrite, all the normal stuff that like you just kind of want, but like don't want to have to implement. Actually, you'll notice there as well, you can even do like Vim style. Oops, color scheme. Change color schemes, whatever. We have a dark color scheme. Anyway, like I said, the UI is pretty early, but the libIDE is coming together pretty quick. So if there's anything in particular you want, email me. I'll probably implement it. So yeah. Right. So I guess the question is like, so multiple cursors in terms of, like I can have multiple. We need to rewrite. Let's start with we need to rewrite GTK text view. So GTK text view has this concept. We can't do multiple cursors because GTK text view has this concept where you have a buffer and you have a view, right? This model view. Great idea. Except for the selection was put in the buffer and not in the view. So like you go to select some stuff, and then you have a different view of it, and the selection updates over here too, right? It's not really what you want. And the other problem, we can't do block selection from Vim is another thing I like a lot. Like Control V and Vim will start doing block selection. Like we can't do that in GTK text view. So we can pretend to do it by like when you like move that direction, I can go and make another something that looks like a selection, but it's not actually a selection. And then when you do other commands like cut, copy, paste, we'll just hijack that and do our own thing. But at that point, we're not that far off from just writing our own new text editor widget. And so I think really what we should do for GTK4 is we should either deprecate GTK text view, which might make some people mad, or we should build something new that's specifically designed for this. If you use the GNOME terminal emulator in the last release or two, it got that nice feature where you resize the terminal and like the lines wrap, and like you don't lose, like when you used to resize it, they would just stay broken, but now everything like flows. So I actually think the text, the design that went into that terminal widget is actually a really good design to take and put into a text editor that isn't a general purpose text editor, but it's a text grid. Because GTK text view deals with variable size fonts. So like when you go down, you're not going down to the same index offset that you were on the previous line with a different font. You're trying to perhaps get to the right position pixel-wise. Whereas a text grid, you're using a monospace font, you're going to drop down to the same offsets. And all of a sudden, all these other things get a lot easier too. And GTK text view has a B tree. So now we have to debug a database and and a text view. So I would like to push that off into something else, and like VTE deals with this. So maybe there's something we can do with that down the line that would be a lot easier. If we can get the gedit people on board, and it sounds like they're interested, but not all of us have like a year PhD thesis timeline to be able to build a new text editor widget. So we'll see what happens. Any other questions? General GNOME questions I can answer? Yes, Nate. So the question is, what do we expect to kind of go with project management? And it's a good question because I really didn't touch on this much in the talk. And project management to me is more of, I need a desktop setting, so I need to use G settings. Well, like knowing that you need to use G settings is like one layer of understanding that isn't necessarily general knowledge. So we need to tie all of that in so you're not thinking about how do I add G settings to my automake build file. It's more of I need settings. Give me a settings editor that I can have, and it deals with getting all of that in there. Or like I need a dbus service. Well, I'm not supposed to put the generated version of the dbus service in my project. I'm supposed to say I'm consuming this dbus service. Here's its description as XML. and I need to generate the C file stubs or whatever language stubs that I need so that I can then implement this debug service. Or I have icons, and I need to install them to the system, but I have no idea where those icons should go. Should they go in like user, share, icons, high color? I have SVG icons, but they're sized at 16, and the nominal value of scalable icons on user share high color actions is 128. Like, what do I do? And I'm sick that anybody has to deal with that, even though it's like all these super technical reasons for things that are just completely irrelevant to application developers.
That's actually a good point. You could use Builder as a tool to kind of force people to do the right way.
Yeah.
So you say it only builds proper GNOME-free applications the way we want you to build them.
Yes.
But that means that every existing application can't be learned to build it because they are applications.
Yeah.
Everyone cheats and does the wrong thing.
Yes. So
how much do you plan to use it as a forcing function, and how much do you want to support it?
yeah, and so the question is how do we want to use Builder to like get people to do the right thing when building software for GNOME and for the Linux desktop in general. It's not that different if you're doing it for something like Elementary OS or any of these other desktops. So I mean, for those that know me, I'm not really a forceful type person. I don't really go tell other people like you should live your life this way. But the thing we can do here is just remove all of that friction of that process. And I think we're going to find that a lot of the other projects, because a lot of the people that have made the GNOME 3 desktop applications, like they contributed to Builder, either to the code or financially. So they have like an interest in this thing being done well. And then this really awesome guy, Philip Withnall, he's at Collabra, has been working on simplifying the build system. So he's been going and taking the Automake code and making it more declarative. Like Automake itself was supposed to be declarative. You didn't write build rules of like, I need to build this .o and it's GCC with this. You said, I have this library, it has these sources, and Automake would go generate all the rules for you, right? In true declarative design. However, we kept getting into all these weird things where we'd have to write custom rules for some stuff, but not everything. So he's been going through and really cleaning up how we do Automake and AutoConf to be able to get back to a more declarative build system with Automake. So like that's something that like I'm really excited about, because it is copy and paste nightmare across the board, across free software. Despite that most people still believe that like we should be using Automake because it handles so much that you don't know that it handles. And it's like it's really the best thing. So there's like switching to CMake is not necessarily going to solve our problems or whatever new build system. So yeah, I think that people will move. Especially on the core GNOME 3 ones, especially when we have an example that's like, oh, hey, set this up, and now it just works. And now you don't have to write custom GUR installers or icon installers. Like the icon stuff is particularly bad because you don't know like how you set up the icons and the SVG files in your project to render them for some toolbar or whatever you have to get it into the proper place is just, I don't know that anyone's done it right. And like it gets fixed in package, like distro packaging. Anything else?
Yeah, you mentioned that you're sharing some components with like GEDI.
Yes.
Have you done similar thing with the Genie editor?
I have not. So the question is, have I been doing any code sharing with Genie? The problem with Genie is that it runs a different code editor that's based on Scintilla. So this is the same. This is actually one of the arguments on why we're not rebuilding on Anjuda. And one of the main problems is that and this is a problem with Anjuda, not with Genie, is that it's built in such a pluggable design that the code editor itself is abstracted. And then you have an implementation of the code editor for GTK Source U and have an implementation of the code editor for Scintilla. And we can't really share code